So today we're going to do Chapter 5, Section 1. Now you might be a bit confused because we've done Chapter 5, Sections 1 through 4, but we used a different textbook. Okay, what we're doing right now is we're starting our introduction into TRIG. Okay, and we're going to spend in our traditional textbook, we're going to spend about 3 or 4 chapters in that. In the other book, okay, I think it's chapter 6 to 8 or 6 to 9, that's all TRIG. We pulled out this particular chapter from an older textbook or a different textbook that we used to use only because this chapter introduces some of the basic trigonometry concepts using degrees, okay? Our textbook, the one we've been using this year, does degrees and radians together. And you might say, well, what are radians? Well, radians are an alternative way of describing an angle measure, let's say. And so we want to, since what you know is degrees, okay, this book focuses all the trig that it's going to teach you in this chapter using degrees. And so that's why, since that's what you know, we're going to start you with that. Once you understand the concepts, then, and we finish this chapter, we'll go back to our old book and start with chapter 6, which will have, it'll be everything you've learned here, but it'll be with radians, okay? So again, we need to understand some vocabulary. First of all, we're going to be talking about angles in a coordinate plane. So you're going to start all of your problems with a coordinate plane, the XY axis. This is your X axis, this is your Y axis, okay? And what we're going to do is we're going to start our angles always here, okay? So our angle is always going to start on that right side of that x-axis, and we're going to call that the initial side, okay? The other side of the angle is going to do a rotation, right? It's going to rotate. Remember, degrees is the amount of rotation from one segment to another. So our angle is going to rotate, in this case counterclockwise, right? And we're going to go so far. In this case, it went to here, okay, and it ended there. So notice this angle was created, this unknown angle. We use this little symbol here. It looks like that, and it's called theta. So when we don't know the angle, we call it theta. And we're like, all right, so angle theta is formed by the initial side in blue and the terminal side that I did in green. So again, where the angle ends, that line where it ends, that's going to be your terminal side. Now, we can do tons of rotations, right? Like I can assume that this rotation has a measure. Let me kind of put the blue back, right? Here's blue, here's the green. And I'm going to assume that this is about 30 degrees. I could be right, I could be wrong, right? But there are some set values that are obvious on a graph. For example, if my terminal side, if I take it over to here and I end it here, okay, my terminal side is now on the y-axis, and my terminal side is now created this angle, which is 90 degrees. What would happen if I put the terminal side right on the initial side? Like if it ended where it started, well, that would be 0 degrees because there would be no rotation there. So I start at like 0 degrees. If I go up, it's 90 degrees. If I go another 90 degrees, I'm at 180. If I go another 90, I'm at 270. And if I go one more 90 and I'll complete a complete rotation and I go back to here, now this angle, my terminal side is on my initial side, but I've done a 360 degree rotation. And so that would be a 360 degree angle. Every rotation I do is 360 degrees. And so again, I could do a whole bunch of, rotations along the way, right? I could, let me erase everything here, right? Let me start again, right? Let me start with, again, my initial side here in blue, and then maybe I want to rotate to here. I don't know exactly what that measure is, but I know it's going to be between 90 and 180. Maybe it's about 120 degrees or so. And I could just keep going. I could go. Now, all of my rotations, you're used to in geometry, we only did about 180 degrees we talked about, which is a straight line, right? However, we can do rotations of really huge numbers, right? So this is 0, this is 360. But imagine if I go one full rotation, that's 360. If I go another rotation, guess what? Now it's a 720 degree rotation. Again, my terminal side is at the same spot, but I can rotate however many times around 0. When I go counterclockwise, okay, I'm going a positive degree. Okay, so if I have 70 degrees, I'm going to go 70 degrees counterclockwise. Now, I can have negative angles, so positive degree or positive angles. Okay. Now, if I go clockwise, that would actually be a negative angle of rotation. So what would happen is, over here, my initial side is here. I start here, and I go in this direction. Notice I'm going clockwise. So this angle here would be, let's say, negative 30 degrees. I'm not sure if it's negative 30, but I'm eyeing it. Actually, it looks more, to be honest, like it's right in the middle. It's probably negative 45. So, and if I did that, then I know this would be negative 90, negative 180 if I went all the way to here, or here, it would be negative 270 or negative 360, right? And I start at 0 and go around. So again, we can do a lot of rotations. We're going to focus most of our stuff on, we're going to learn about these other rotations, but we're always kind of trying to think about the basic 360 degree rotation. Another really important thing that you want to make sure that you keep in mind is your quadrants, okay? You want to know that this is quadrant 1, and quadrant 1 is from 0 to, let's say, 90 degrees, right? Or within that. You want to know quadrant 2 is, between 90 and 180. Quadrant 3 is between 180 and 270, and you want to know that quadrant 4 is from 270 to 360. So if I give you an angle and I tell you to draw it, and it's a 300 degree angle, you know that you're going to start on your initial side here, and you're going to go around into quadrant 4. That angle is going to end up, that terminal side is going to end up somewhere in quadrant 4. Okay, because you know that 300 or 330 degree angle is going to end up in there. So again, just some basic terms. Now we come here and we talk about coterminal angles. And so we kind of showed you a couple coterminal angles, even though I don't think that I mentioned it when I did it. But it's basically where you have the same initial side, okay, and terminal side. So you start and end in the same place, but one has more or less revolutions or rotations around the circle. So for example, let me show you what I mean by that. Let's say I come over to here and I start here with my initial side, and I'm going to go, just like we talked about, I'm going to go 30 degrees. Okay, so this is my terminal side. So what if I start with 30 degrees and I want to know more angles that are coterminal? In other words, more angles that end at 30 degrees. Well, what if I'm going to do it in, let's say, I'll do it in red here. What if I do one full revolution and then I go to here and I end there? And so now I have this, I end on the same place. What I did was I went 360 degrees plus 30 more. So 390 degrees is coterminal with the 30 degrees. It starts and ends in the same spot, but one did a revolution or a full rotation. If I was to go around again from there and back up, then I know that I did 2 revolutions, which are 720 degrees plus 30. That's 750 degrees. So these are all coterminal angles. They have the same initial side, same terminal side, yet they definitely represent different degree measures. Now, what if I go in the other direction? What if I start here at the initial side and I go in the counterclockwise direction. So that would be negative 330 degrees. That would be a negative 330 degree rotation, but it would still get me to the same terminal side. And so there can be positive and negative angles that are coterminal. So what's the trick to it, right? Well, you take the initial angle, 30, and every time you add or subtract 360 degrees, you're going to get to a coterminal angle. So let's add, look, I'll show you, right? If I add 360 to 30, I get 390. If I add another 360 to it, I'm going to get 750, which is what I got in the drawing, right? And if I subtract, if I do 30 minus 360, I'm going to get negative 330. If I do minus 360 again, I'm going to get negative 690. And I could again find all these negative coterminal angles. So I can go to infinity finding coterminal angles. What's important is you want to find, I would prefer that you find coterminal angles, okay, within the range, okay, within the range of 0 to 360 degrees. Okay, I would love, that's really what we're focusing on in this class, because we're going to use those coterminal angles between 0 and 360 to solve a lot of our problems. And so that's really what I would like you to do. So when I ask you to list them, obviously if you need a negative one, you're going to have to give me a negative one, right? But then the positive ones, I'd prefer that they get closer to this. So, you know, and try to make the negative one maybe between 0 and negative 360 or something like that, okay? So now we're here and we have 908 degrees. And again, if I want to find two coterminal angles, one negative and one positive, I could add 360 to this, but that's just going to take me to a big number that I don't really want to do. So what I suggest you do is just start subtracting 360 from this 908, right? You're going to get 548. That's coterminal. If I subtract 360 again, I'm going to get, I hope I'm doing the math right, 188 degrees. That's a second coterminal angle. And if I subtract 360 a third time, I get negative 172 degrees. So I'm going to use the 188 degrees value because that's in that 360 range, and I'm going to use the negative 172 degrees to solve this problem. Now, all of these, though, are coterminal, and I do know that. I know this is coterminal, and this one. But again, I would focus on finding the ones in that first 360 degrees. Thankfully, you have a calculator. I don't suggest doing this math in your head, so make sure you just use your calculator, okay? Again, here, I'm at negative 203 degrees. So if I add 360 to this, I'm immediately going to get, so negative 203 plus 360, I'm going to get positive 157. So there's my coterminal positive one. Now, what I'm going to have to do is I'm already in the negative 203, so I'm going to have to subtract 360 to get a second negative one, okay? So basically, it's going to be 365. So negative 563 degrees is going to be another coterminal to this one. So again, we can't always get it in that range we'd like, but they're still correct answers, okay? And then again, we go to the next few. So here I have negative 75, and I'm going to add 360 to it, and I'm going to get negative 75 plus 360 equals 285 degrees. So that's one coterminal angle. That's the positive one. And minus 75 minus 360 is going to be minus 435. And so there's my negative coterminal angle. And then I go to the last problem here with I have 699, and it's positive, so I'm just going to start subtracting 360 from there. So minus 360 is going to give me 339. So that's one coterminal angle. And if I subtract 360 from that, I should get my negative angle. And that's going to be minus 21 degrees. And so there's my two coterminal angles. Okay, so that's how we do that. This should be pretty basic for you guys. Now here's where we get to something where, honestly, it's kind of annoying, I'll be honest with you. You do want to know how to do this. Again, we have to prepare you for questions you're going to see on SATs and ACTs and things you're going to need to know how to use. And this is one of them. We don't use it too much, but we do use it. So it's degrees, minutes, and second notation. And they call it DMS, okay, D, M, and S. And it is a way to take a decimal degree and you convert it into this degree, minute, and second notation, okay? A degree is always uses the little circle that we use that you know for the degree symbol. The minute uses a single quotation mark, and the second uses a double quotation, or like a quotation mark. I don't even know like how to refer to it, but you see it, the 1 tick and the 2 tick, okay? And you're going to be asked to take a decimal degree and convert it into degrees, minutes, and seconds. And it's just a different way of expressing a decimal degree. There's just no other way to say it. It's just a more specific way of expressing it, and there's a process to it. And when you learn the process is so easy. Don't overthink it. Just learn the process, okay? So if we give it to you in DMS form, you want to know how to convert it to a degree. And if we give it to you as a decimal degree, you want to know how to convert it to the DMS, okay? It's very similar to basically 1 degree, okay, equals 60 minutes. So you have to think of a degree as an hour, because it's kind of like time, okay? It works the same as time. So if 1 hour is 60 minutes, 1 degree is also 60 minutes, okay? And then 1 degree is also 3,600 seconds, okay? We know that because seconds are 60 times 60. So again, you don't even really have to memorize all that. I will show you how to go about doing it, but that's where this all comes from. So when you're given the problem in the first 2 forms, where you're given the problem in DMS form, see, this is DMS, degrees, minutes, and seconds. Let me kind of go over that. It's 74 degrees, 8 minutes, and 14 seconds. The second problem, number 6, is 165 degrees, 51 minutes, and 9 seconds. Notice there's no decimals in this answer. There will absolutely be no decimals in this final answer. Now, how you solve it is this. First of all, you take the degrees as they are, and that's going to be in your decimal, because you're going to convert this to decimal. That's going to be the whole number. It's going to be 74 point something. The minutes and the seconds are what you're going to convert to the right side of the decimal point, okay? And how we do it, I'll show you how simple it is. You're basically going to take, what you're going to do is you're going to take the degree 74 plus, you're going to take the minutes divided by 60. You're going to add it to it, and you're going to add the seconds divided by 3,600 every time. So whatever the minutes is, it's over 60. Whatever the seconds is, it's over 3,600. So when you go to your calculator and you actually do 8 divided by 60, you're going to get 1.333, or not 1.333, I'm sorry. You're going to get 0.1333. You can stop at 4 places, okay? And when you do 14 divided by 3,600, you're going to get 0.0039. I'll round it to 9, okay? And then what you're going to do is you're going to add that up. So you're going to do 74 plus 0.1333 plus 0.0039. And when you get your answer, you're going to get 74.1372. That is the degree of this DMS form. It's converted. That's your answer. So one is in degree form and one is in DMS form. And we're going to do the same thing for the second one. So again, the second one, you take your degree, 165. It's going to stay like that. Your minutes, 51 divided by 60, plus your seconds divided by 3,600. And again, the reason is because there's 60 minutes in a degree and there's 3,600 seconds in a degree, just like time. So again, you're just going to go to your calculator, 51 divided by 60, you get 0.85. So here's 165 here. And then here, 9 divided by 3,600, and you're going to get 0.0025. And then you're going to add those together. So 0.85 plus 165 plus 0.0025, and you get 165.8525. And that's your answer. And again, because you're converting to degrees, there's your degree symbol. Okay, and so that's the answer to convert. Now we come here to 34.817, and this is in decimal form, okay? And I want to convert this to DMS, right? So I'm going to take this first part, because remember, what's in the front there, that's my integer, that's my degree. And then I'm going to take the leftover decimal part, and I'm going to identify my minutes, and I'm going to identify my seconds. So what I do to identify my minutes is I take the decimal as it is, 0.817, and I multiply it by 60. And when I do that, okay, I'm going to get 49.02. And just like with the 34, I took the whole number part of it and I made it my degree. I'm going to take the whole number part of 4902 and I'm going to make that my minutes, okay? And then I'm going to take, for my seconds, I'm going to take the decimal part of 49.02, the 0.02 part, and I'm going to multiply that by 60. So again, 0.02 times 60, and I'm going to get 1.2. And again, I'm going to take the whole number part of it, and that's going to be my seconds. And so this combination of 39 degrees, 49 minutes, and 1 second is the DMS form of my answer, of my decimal. So this is the DMS form, like that. And so again, it's weird. I'm just going to multiply the decimal portion of each thing by 60, and the whole number part of it becomes the minutes or becomes the seconds. Again, we'll do one more, and I think it'll make sense to you. So we start here with 59. So I know that in DMS form, that's 59 degrees. Then to find my minutes, I'm going to take the 0.08754 that's left over, and I'm going to multiply it by 60. So 0.08754 times 60, and I'm going to get 5.2524. And so this 5 is going to become my minutes. Now the decimal part of that answer, which is 0.2524, is going to be multiplied by 60, and that's where I'm going to get my seconds from. So again, 0.2524 times 60, and I'm going to get 15.144. And again, I'm going to take that whole number part of it, and that's going to become my seconds. And so this answer in DMS form is 59 degrees, 5 minutes, and 15 seconds. And that's just a different way of describing a degree. And the truth is that they're exactly the same. I mean, they're going to point to the same exact angle measure, or if I was to be using like latitude and longitude, they use degree measures to find locations. It's going to take me to the same locations on a GPS map or anything else. They are equivalent. It's just different ways of writing the same thing.